Hello, welcome back to another exhilarating video about Algebra 1. This is a video over Unit 9, Section 4, and we're going to be talking about solving quadratic equations by completing the square. This is a very powerful way for us to solve quadratic equations, okay? And what we first need to understand is the concept of a perfect square trinomial, okay? And that is, and let's write this in here, a perfect square trinomial is a trinomial that has two of the same factor, okay? And that's important that we have that written down, okay? And let's just talk about this real quick. When we talk about x squared plus 6x plus 9, when we factor that, yes, you do get x plus 3 quantity squared, but what that means is that you get x plus 3 times itself, okay? And this is what I mean by two of the same factor, okay? That's what it means to have a perfect square trinomial, okay? So that when you factor, your factors are the same, and you can write that as a quantity squared, okay? Now, the interesting thing is that, we first start off with this expression here, okay? X squared plus 6x plus c, okay? And what we are going to do is we are going to create, okay? So our goal here is the ability to create perfect square trinomials, okay? So create perfect square trinomials. Okay, and this can be easy to an extent, and then it kind of gets tricky. But here's what I got. Okay, let's write this down. Let's write down x squared plus 6x plus c. And my question is how do we create this variable c so that this entire thing is a perfect square trinomial? So what we want to do to get the value for c is that c is equal to our middle term, okay, and let's do this. Our middle term b divided by 2 quantity squared, okay? And this would take the form, okay, this comes from something of the form a x squared plus bx plus c, okay? So the value c, in order for this to be a perfect square trinomial, we take our middle term, we divide it by 2, and then we square it. Okay, so what I'm going to do here is I'm going to take our value, which we had, which was 6, not b, divide it by 2, and then square it. So then c is going to equal 3 squared, so then c is going to equal 9. Okay, and so what I do is we have to create this, okay? And so then we get x squared plus 6x plus 9, and this is now my perfect square trinomial, all right? And so x squared, or then this is going to factor to x plus 3 times x plus 3. If I have something times itself, I can write that as x plus 3, that quantity squared, okay? And that's what we have, all right? Okay. Now, if you look over here in this part, and I'm going to talk more about what we do here, but when we are completing the square, okay, this is going to allow us to, solve these equations, okay? It's going to allow us to take something that was x squared and turn it into a quantity squared, and then, once you have that perfect square trinomial, you can take the square root of that, and you get rid of the square, and you get x plus 3 is equal to plus or minus 5, okay? And you would solve this equation from there. All right, but here's the cool thing about completing the square, okay? This allows you to solve, so let's write this down, allows you to solve any quadratic. Okay, it's pretty powerful, all right? Because sometimes you can solve them, you aren't able to solve them, by using, factoring and all that, but this allows you to solve any quadratic, okay? So let's go through about how we actually complete the square, okay? And let's go read through some of these steps, and we will go through and solve this, okay? Solving an equation by completing the square. First, we want to isolate the constant, okay? The constant is this value here. So in order for me to complete the square, the first thing that I have to do is do this, okay? I'm going to have x squared plus 8x plus blank is equal to 9 plus blank. Now, the reason why I'm doing this to both sides is because if I do it to the left side, I also have to do it to the right side to be balanced, okay? This value here, this blank, is where my C value is going to be, okay? And so now that's the first thing, all right? That's step one, isolate the constant. Then what we want to do in step two is form a perfect square trinomial keeping the equation balanced. So again, what I have to do here, adding my value to this side, I have to add it to this side. So let's take this middle term here. All right, I'm going to take 8. I'm going to divide it by 2. And then I'm going to square it. Okay, now if I take 8 divided by 2, that's going to end up giving me 4. So I've got the value of 4. That quantity is going to be then squared. And then we get a value of 16. Okay, so this is what's going to go into my blank. All right, so I've got 16 on this side, and then I'm going to add 16 over on this side. Okay. Now, the next step, and we could do this, I'll just go x squared plus 8x plus 16. We want to combine the 9 and the 16. That's going to give me 25. All right, so now what I have here is that I've got x squared plus 8x plus 16. Okay, I want to factor this. Now, when you factor this, you can use the box method. You can use whatever you want. But two numbers that are going to multiply to 16 and add to 8, and that's going to be 4 and 4. So this is going to factor to x plus 4 times x plus 4, and we'll set that equal to 25. Okay. Now, if I have x plus 4 times x plus 4, all right, that's the same thing as writing x plus 4 quantity squared is equal to 25. Now what we have is we have created what we were solving in the last class period, where I have a quantity squared is equal to a number. Now to get rid of my square, I simply just want to apply the square root to both sides, okay? And then what I'm going to be left with is x plus 4 is equal to plus or minus 5, okay? And then if I want to solve this equation for x, okay, I'm simply just going to subtract 4 from both sides, and then we're going to get that x is equal to negative 4 plus or minus 5. So now I've got that x is equal to negative 4 plus 5, and I've got that x is equal to negative 4 minus 5. So negative 4 plus 5x is going to equal positive 1. Over here, x is going to equal a negative 9. Okay, and that is my answer. Okay, and so that's the idea. All right, so we did all these steps. I kind of just went through it because, once you create that perfect square trinomial and then you factor it, then you are just doing what you were doing in the last section, okay, and solving that equation for x. All right, so that's what we did. We wrote the trinomials of binomials squared. We used the square root property of equality over here, and then we isolate the variable and solve for x, okay? So pretty cool, all right? Okay, so let's take a look here at comparing the different methods of answering this same question, okay? So completing the square is in this column, and then factoring using the zero product property is over here. So what I want to do is take a look at completing the square, okay? And so what we've done over here, x squared minus 6x equals 7. Okay, what we've done is we've turned this part into a perfect square trinomial, okay, and we did that by taking negative 3 divided by, or I'm sorry, negative 6 divided by 2, squaring it, and that's going to give you negative 3 squared, which is going to give you a positive 9. Okay, that's what the value here and here. Okay, and then if you apply the square root to both sides, okay, then you just get x minus 3 is equal to plus or minus 4. Then you get x minus 3 is equal, no, you don't do that. You want to add 3 to both sides first. Oops, sorry. So then you get that x is equal to 3 plus 4, or you get x is equal to 3 minus 4. All right, so here you're going to get that x is equal to positive 7, and here you're going to get that x is equal to negative 1. All right, so you got that, and you got that. All right. Now over here, we want to let's factor this and use the zero product property. So instead of, we've isolated the 7 here, you've subtracted it from both sides to get it over here. So you have this equation. Let's factor this, okay? And this is going to factor to x minus 7 times x plus 1 and set that equal to 0. Okay, I can set my factors equal to 0, so x minus 7 equals 0, and then I've got x plus 1 is equal to 0. All right, so if I'm going to add 7 to both sides, I'm going to get that x is equal to positive 7. Here I'm going to subtract 1 from both sides, and I get x is equal to negative 1. Now look what we did. Okay, notice that we get the same answers no matter which method we do. Okay, here's the caveat. Here's the problem. What's going to happen is that you're going, this is a factorable trinomial. Not every trinomial or quadratic is factorable, okay? And that's the key, all right? If they were all factorable, then we would just always do this. But they're not always factorable, okay? Therefore, that's what's so powerful about completing the square. Okay, we're going to get some weird answers, but that's just the idea. All right, so let's go ahead and let's do something a little bit different, okay? And on this, we're going to examine a quadratic with an odd coefficient, with this guy as a 5, okay? We want to isolate the constant, which we've done, okay, negative 4. Form a perfect squared trinomial, keeping the equation balanced, okay? So same steps as we had, but this is going to be a little bit different, okay? Now, here's where things are going to get fairly uncomfortable, okay? Which is, pretty standard for my life. It's just a bottomless well of uncomfort. Anywho, so let's do this. Let's take our middle term, which is 5, okay? And I'm going to divide that by 2, and then I'm going to square it, okay? Now, over here, I'm going to take 5. In order to do this, I need to take 5 squared over 2 squared. Okay, and 5 squared is going to give me 25. 2 squared is 4. Okay, so this is the value, 25 fourths, that we are going to add to both sides. So I'm going to put 25 fourths here, and I'm going to put it here. Okay, and then what I want to do next is solve this equation. Okay, now what I have done here, and it doesn't look like it, but we have created a perfect square trinomial. The question is that factoring this now becomes a pain. This is going to be hard, okay, because we have fractions, okay? So because it has fractions, factoring this and asking yourself the question, what two numbers are going to multiply to 25 fourths, but then add to 5? This part sucks, okay? However, there is a pattern here, and I want you to see the pattern. I'm going to go through each of these problems real quick. I want you to notice something. I want you to notice what happens when I take this middle term here, divide it by 2, and then square it. Notice that this number here, this 3, and this 3 match up, okay? That's crucial, okay? Notice the same thing here. Notice that the 4 here, when I took my middle term here, 8, divided by 2 and then squared it, I got 16. Notice that my 4 pops up here and here. Notice in the next one that when we took our middle term here, negative 6, and divided it by 2, we got negative 3. Notice how that number pops up here, and then it pops up here. So the trick is, the pattern that you need to see is that in this, in order for me to factor this, this is going to become this value here, my middle term divided by 2. So I'm going to write this as x plus 5 halves times x plus 5 halves. If I add 5 halves together, they're going to give me 5. If I multiply them together, they're going to give me 25 fourths. That's the key. That's what you guys need to see here, all right? Now, you'll want to do a lot more practice with this, but that's where you're going to get that, okay? So then, over on the left side, you're just going to get x plus 5 halves quantity squared. And you have turned this into a perfect square trinomial, and then you factored it. And you really don't have to do much thinking because the thinking has been done for you if you see this pattern, okay? Now, over on the right side, let's combine these. I'm going to do negative 4 over 1 plus 25 fourths. I'm going to get a common denominator of 4, so I'm going to multiply the top and bottom by 4. Okay, so then here I'm going to get negative 16 fourths plus 25 fourths. Now, when I have negative 16 plus 25, that's going to give me a positive 9 fourths, and that's going to equal x plus 5 halves squared, okay? Now, we're back to that same problem that we had, all right? Now, the cool thing is that we're still doing the same thing, okay? Even though we've got fractions, our process doesn't change. I'm still going to apply the square root at this point and apply it here. Now, when I get that, this is just going to give me x plus 5 halves on the left side, and then I'm going to do plus or minus, and I need to take the square root of my numerator and the square root of my denominator. And here's what we're going to get. We're going to get x plus 5 halves is equal to plus or minus 3. Square root of 9 is 3. Square root of 4 is 2. So here's what I got, okay? And let me do this. Let me subtract 5 halves from both sides. All right? So I get that x is equal to negative 5 halves plus or minus 3 halves. Now, because I have a common denominator here with the 2's, I can combine these as 1. And I can write this as negative 5 plus or minus 3 all over 2. Now, the cool thing is that I'm not done. Okay, I can continue to answer this question. And let's write this as 2 different expressions. So x is equal to negative 5 plus 3 over 2. And then we've got x equals negative 5 minus 3 over 2. Okay, so we still want to do that. So here I've got x is equal to negative 2 over 2. So then x is going to equal positive 1. All right, and then over here I've got that x is equal to negative 8 over 2. So then x is going to equal negative 4. All right, and so those are my answers. So things do get much, much, much trickier when you add in fractions, but guys, I'm not doing anything different, okay? I'm doing the same thing that I was doing up over here or in the previous examples. It's just that now I have a different, I've just got fractions, okay, and that's it. All right, so let's just jump in right here and answer these questions. The cool thing is on this part, I've already isolated my 7/4. Okay, that's kind of nice. So let me write this. Let me zoom in and write this as x squared plus 3x plus blank is equal to 7/4 plus blank. That's my first step. Second step, okay, let's turn this into a perfect square trinomial. So I'm going to take the 3. I'm going to divide it by 2, and then I'm going to square it, okay? Remember this 3 halves. We're going to need it. All right, now if I take 3 squared, okay, 3 squared over 2 squared, all right, that's going to give me 9 over 4. So this is the value that's going to go here, 9/4, and then 9/4. All right, now over on the left side, we have turned this into a perfect square trinomial. Now this, my middle term divided by 2 is going to help us factor. So this is going to then become x plus 3 halves times x plus 3 halves. All right, now if I've got 7 plus 9 over 4, 7 plus 9 is going to give me 16 over 4, okay? So that's nice, common denominator, that helped. Now over here, I've got the same thing multiplied by itself. So I'm going to write this as x plus 3 halves quantity squared, and then that's going to equal 16 divided by 4, which is just 4. Now I'm going to apply the square root to both sides, okay? And so then I'm going to get this. I'm going to get x plus 3 halves is equal to plus or minus 2, okay? So now here's what I got. I'm going to subtract 3 halves from both sides. All right, so I end up getting that x is equal to negative 3 halves plus or minus 2. Now, what I want to do is get a common denominator here and combine these, okay? So I get that x is equal to and let's do this. I'm going to put this over 1, multiply this by 2 over 2, all right? So I've got x is equal to negative 3 halves plus or minus 4 halves, okay? Now, with that, I'm going to get negative 3 plus or minus 4 all over 2 to get a common denominator, all right? So we're not done. Okay, we're going to write out two different equations. X equals negative 3 plus 4 over 2. And we're going to write x is equal to negative 3 minus 4 over 2. Now, negative 3 plus 4 is going to give me positive 1 half as my first answer. Over here, negative 3 minus 4 is going to give me negative 7 halves. And those are my answers. Okay, so doing this the other way and factoring this isn't going to happen. Okay, but we can do completing the square to help us arrive at our answers. Okay, all right, finding irrational solutions. All right, now let's do this. We're going to solve this equation. Can't factor it, and you can try. That's the thing. You know, always try and see if you can factor it. I'll tell you this right now. The majority of problems in this section you won't be able to factor. Okay, so let's do this. I'm going to rewrite this. I'm going to reorder this as x squared minus 10x plus 2 equals 0. Put it in this form. Now, when I have it in this form, and you're like, okay, I tried to factor it and I can't, we want to solve this by completing the square. So I'm going to subtract 2 from both sides, and I get that x squared minus 10x plus blank is equal to negative 2 plus blank. Okay, now I'm going to take negative 10, I'm going to divide it by 2, and then I'm going to square it. Okay, so it's going to give me negative 5. We're going to need that number later, okay, and then we're going to square it, okay. So now negative 5 squared, that's going to give me a positive 25. So let's do this. Put a 25 here, and let's put a 25 over here. Okay, now this is a perfect square trinomial. This one's pretty easy to factor, okay, but we are just simply going to have x minus 5. That was our value that when we divided that by 2. So we're going to get x minus 5 times x minus 5, and that's going to equal negative 2 plus 25 is going to give us 23. Okay, now x squared minus 5, or x minus 5 times x minus 5 is just going to give us x minus 5 quantity squared is equal to positive 23. Now what I want to do is apply the square root to both sides. Now when I apply the square root, I get x minus 5 on the left side, but then I get plus or minus the square root of 23 on the right. I can't take the square root of 23. So that we can't simplify, all right? And we're just going to leave it like that. Then to solve for x, I'm going to add 5 to both sides, and we're simply just then going to get that x is going to equal 5 plus or minus the square root of 23. Now you can write your answer like this, and that's fine. That would be acceptable, but you will have two answers. You've got x is equal to 5 plus the square root of 23, all right? And then you've got x is equal to 5 minus the square root of 23, okay? And that's what you have, all right? So you have two answers here. All right, so now let's take a look at what we had here. So relate the zeros of this function, or relate the solutions to the zeros of this function. Now we talked about this in the last section where we would solve by factoring and do that thing and check our solutions graphically. This is a little bit harder, okay? Now here's what we got. Here are our solutions to this. We've got that x is equal to 5 plus the square root of 23, and we've got that x is equal to 5 minus the square root of 23. Now, these are what we call irrational numbers, meaning that the decimals are going to just be really long and they're never going to end, okay? But let's go. I'm going to plug these into Desmos real quick to see what these values are, and I'm simply just going to type these in. Okay, now these are the values that we get, okay? This is, this value here is that x is approximately 9.796, okay? And then the next one would be that x is approximately 0.204, okay? So these are my two approximate values. Now, if you're checking this, all right, what we can do is simply just go in and then graph these, okay? And graph this equation, and let's see where it crosses the x-axis. So let me plug that into Desmos as well, and let's see what we get. Okay, so now that we've done this, and hopefully you guys can see, but we get the same thing, okay? We get 0.204, okay, as our x value here when it crosses the x-axis. And the same thing over here. We get 9.796 over here. So a lot of times it's easy to do it, but when you have these irrational numbers as solutions, okay, that's how you can check graphically as to what they are, all right? So let's go ahead and skip this last one, and we'll finish up the video right there. So hope you enjoyed this, and we'll talk to you soon. Thanks a lot. Bye!